Now the first type is histogram stretching. The basic simple formula for this histogram stretching is S, that is modified the sorry S modified image S can be represented by a transformation on input image R. S, that is output image, R is the input image, and T is the transformation. Now what is the transformation? This transformation is nothing but S max minus S minimum divided by R max minus R minimum, that is S max S minimum जो desired output है, that is S, that is along your y axis, and this is R max R minimum, or you can say the modified output input ये input है, and then R, that is input R at present जो situation में जो भी R रहेगा, that is the input value रहेगा, you have to subtract the R minimum from the original value input image, and you have to add S minimum. Okay, now why do we require the histogram stretching? If we have the histogram which is situated from this region to this region, it is not covering the entire range, that is 0 से लेके 255, that is 0 to L minus 1. It is starting from 84 and it ends at 153. It does not start from 0 and end at 255. Whenever I want to start from the minimum range and I need to end the same pixel value at L minus 1, I need to stretch. I need to stretch this end to this and this end to this. And I need to distribute the pixel value in between 0 and L minus 1. At that time means what? I am increasing the dynamic range. I can visualize my image for the minimum value as well as for the highest L minus 1 value. Means I am extending the dynamic range for the input image. For example, suppose you have the number of pixel and the input gray levels 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0 repeats 0 time, 1 repeats 0 time, 2 repeats 20 times, 3 repeats 10 times the number of pixels for 4 30s, then a number of pixels for 5 40, then 6 repeats 0, 7 repeats 0. If I plot a histogram for this, my histogram will look like this. Okay, means it starts from 2, ends at 5. It is not covering 0 and 7, that is L minus 1. Okay, now from the diagram or from this table I can actually have the different level of S and R. So S max, that is a 7 that I want to cover L minus 1. Hmm. If it is 3 bits per pixel, 2 raised to 3 8 8, L minus 1 will be, so S max is always L minus 1. S minimum is always 0. Okay, 0 and L minus 1. So S minimum, that is the desired minimum value, should be 0 and desired maximum value should be 7 L minus 1. R max, that is R max, that is input is at 5 and R minimum is 2, then 5 2. So I have S max, S minimum, R max, and R minimum, R minimum, S minimum. I have R also. So first, when R is equal to 2, when R is equal to 2, I need to calculate the S. So by keeping R is equal to 2, S max 7 minus S minimum 0, R max 5, R minimum 2. So 7 by 3. Okay, 7 minus 0, 5 minus 2, that is 7 by 3, that is 2.33 something, multiplied by when R is equal to first gray level, that is 2, for gray level value 2, minus R minimum is 2, 2 minus 2 is 0, 0 multiply by 0 will be 0, plus S minimum is 0, 0 plus 0 will be 0. So when R is equal to S is equal to 0. Hmm. Then when R is equal to 3, then again 3 here, you will replace the R value 3. You have S max, S minimum, R max, R minimum, R minimum, S minimum. You will calculate the value S. When R is equal to 3, S is 2.33, that is approximately 2. The approx value for the 2.33 is 2. After rounding down, the value is 2. 4. Similarly, 4.66 rounding up. We rounding up when you hit 0.5 and above. So 5. For 5, 6.9, and that is a 7. So you have covered from 0 से लेके L minus 1 7. When you were having 2 to 5, that is R minimum 2 and R max is 5. Now you have the new value, that is S minimum 0 and S max 7. Means you have stretched from 0 to 7. What will be the output? Now you have a new value. Now 0 repeats 20 because 2 has 20. 2 has a 20. Now you have a new input gray level, that is a 0. Now 2 will be represented at 0 now in the output because you have stretched. So जब यहाँ पे था, now I am starting from new gray level value, that is 0 repeats 20 times because 2 का value इधर 20 है, तो ये 2 का value 0 को लग जाएगा, 3 का value यहाँ पे 10 है, ये 2 को लग जाएगा, 4 का value यहाँ पे 30 है, it will be considered for 5 level, and for the 5 the 40 number of pixels are repeating, so it will be considered for the 7. So I will redraw the graph like this. Okay, so that will be HK, the number of pixel for that particular output gray level, the output gray that is stretched. So before stretching the histogram, my histogram was very limited, or you can say this is nothing but the power distribution function or power density function. The range was very limited from 2 to 5. After stretching, it has been covering from 0 to 7. I have increased the dynamic range of a histogram. So this is histogram stretching.